We now learn about arithmetic sequences. And for that, consider the sequence that we have here. We have 3, 7, 11, 15, and 19. And this is an arithmetic sequence, and what makes it arithmetic is the fact that to get from any one term to the next, I'm always adding the same amount. Indeed, you can probably see right away here that to get from the first to the second term, I'm adding 4. From the second to the third, I'm adding 4 again. From the third to the fourth, I'm adding 4, and so on. The amount we always add is known as the common difference. So I'll just write that. That's common difference, and we usually refer to that common difference with the letter D. So in this case, D would be equal to 4. And it is worth insisting for a second that a sequence can only be called arithmetic or arithmetic if we're always adding the same amount to get from one term to the next. Here's what I mean. If I just erase those 3 dots there for a second, and just imagine if the next term were 24 followed by 28 and so on. Now, if that were the case, then this sequence would no longer be an arithmetic sequence because we can see that to get from 19 to 24, I'm actually adding 5. Since this isn't the same amount as what I'd been adding previously, it wouldn't be an arithmetic sequence. That being said, let me just erase that. There we go. Now, if I were to ask you to find, say, the next 3 terms of the sequence, then I'm sure you'd have no trouble in telling me that the next term would be 23, followed by 27, followed by 31, and we could carry on that way. But what if I asked you for the 105th term? So I'll just say that 105th term, with a question mark there. Now, one way of finding the 105th term would be to keep on adding 4 to each of the terms of our sequence until we reach the 105th term. But I'm sure you can appreciate that would take a long time. And so rather than doing that, we're going to use what we call the formula for the nth term of the sequence. And for that, let me quickly remind you of a bit of notation here. The first term of a sequence is called u1 or u sub 1. The second term would be u sub 2. The third term would be u sub 3. The fourth term would be u sub 4, and we could carry on that way. And so when we say that we're looking for the 105th term, we would write that we're looking for u sub 105, right? That's what we're after. Now, the formula for calculating any term of an arithmetic sequence directly is the following. U sub n equals to u sub 1 plus n minus 1 times d. And I'll go ahead and box that formula. Do make a note of this. That's the formula for the nth term. Formula for nth term. Now, just to be clear, thanks to this formula, I can calculate any term I want inside this sequence. All I need is the first term, u sub 1, which we have here, that's 3, as well as d, which remember is the common difference, which in this case is 4. So for this particular sequence, the formula for the nth term would look like this. We'd have un, the nth term, equals to u1, which is 3, so I write that, that's 3, plus n minus 1 times d, and d, remember, is 4. So I write that here, that's n minus 1 times 4. Now, before calculating the 105th term, let's see how this actually works. To calculate any term we want inside the sequence, all we have to do is replace every n that we see inside this formula by the number of the term we want. So for instance, let's say I wanted to calculate the 6th term. In other words, I want to figure out what u sub 6 is. Well, first of all, we have the 6th term up here. And that gives us something we can check with. So if I just erase those 3 dots, and so the 5th term would be u sub 5, which is here, that's 19, and the 6th term would be u sub 6, which is 23. So we already know that u6 should equal to 23, but if I go ahead and calculate that to show you how to use the formula, u sub 6 would be equal to 3 plus n minus 1, where n is 6, that's the 6th term, so that's going to be 6 minus 1 times 4. And that's equal to 3 plus 6 minus 1, which is 5, times 4. And that's equal to 3 plus 5 times 4, which is 20. And finally, the 6th term, u sub 6, equals to 23, which comes as no surprise because that's exactly what we had here. And this just confirms that the formula works. And the good news is, to calculate any term of the sequence, we use the same method. All we do is replace n by the number of the term we want. So to calculate the 105th term, all we would have to do is go ahead and say, okay, well, we're looking for u sub 105, and that's therefore equal to, well, let's see, remember, I'm using this formula here that I'm boxing in purple right there. That would be 3, remember that's the first term, plus n minus 1, so in this case n is 105, so that becomes 105 minus 1 times 4, and that's equal to 3 plus 105 minus 1, which is 104 times 4, and that's equal to 3 plus 416. And finally, we can say that the 105th term of this sequence is equal to 3 plus 416, which is 419. And we're done. And so that's how we can use the formula for the nth term of an arithmetic sequence. Notice that all I needed to define it was the first term, which was 3, and the common difference, which was 4. Let me quickly show you one more example. So I'll just go ahead and write a 1 here to say that was example 1, and let me write a 2 over here. And I'll go ahead and quickly define a sequence. I'll say 22, 19, 16, 13, 10, 7, and so on and so forth. Now, this again is an arithmetic sequence, and as we go from left to right, in other words, as we go from one term to the next of the sequence, we may think that as we go from left to right, we're not always adding the same amount, but instead of that, we seem to be subtracting the same amount each time. Indeed, to get from 22 to 19, I'm subtracting 3, and to get from 19 to 16, I'm subtracting 3 again. From 16 to 13, I'm subtracting 3, 13 to 10, negative 3, and from 10 to 7, I'm subtracting 3 again. But it's important to realize that when we subtract 3, we can think of that as adding negative 3. So the common difference, which remember is the amount we always add to get from one term to the next, would be d, which equals to negative 3. And I'll go ahead and box that. There we go. Now, just as in the previous example, we can define the formula for the nth term of this sequence. And for that, remember that all we need is the first term. So in this case, that's u sub 1 equals to 22. And the common difference, which is negative 3. And so using the formula for the nth term, that's what I have boxed in orange here, we can go ahead and state that u sub n is equal to u1, which is 22, so I'll write that, that's 22, plus n minus 1 times d. So that's going to turn into n minus 1 times d, which is negative 3. And that's the formula for the nth term of this second sequence. And just as I did for this first example, let's quickly check that this actually works. And for that, let's go ahead and calculate the fourth term, so u sub 4, which we have at the top here, so we could quickly check the value. Indeed, we know that u2, the second term, is 19, u sub 3 is 16, and u sub 4 should be 13. So let's check if that's indeed the case. So u sub 4 should be equal to 22 plus n minus 1, but in this case I replace n by 4. So that turns into 4 minus 1 times negative 3. That's equal to 22 plus 4 minus 1, which is 3, and that's 3 times negative 3. I'll put a little dot to say I'm multiplying. And that's equal to 22 plus 3 times negative 3, which is negative 9. And finally, that's equal to 22 minus 9, so that's u sub 4 equals to 13, which confirms that the formula does work. Indeed, the fourth term is equal to 13. All right, just to finish, let's say we need to calculate the 101st term of this sequence. Well, again, all I'd have to do is use my formula for the nth term of this sequence and replace every n I see by 101. So I'll do that here. If I need to calculate u sub 101, then that's going to equal to 22 plus n minus 1, which becomes 101 minus 1. So I'll just write that. That's 101 minus 1 times negative 3. That's equal to 22 plus 101 minus 1, which is 100 times negative 3. That's equal to 22 plus 100 times negative 3, which is negative 300. And that becomes 22 minus 300. And finally, the 101st term of the sequence is equal to negative 278. And there we go.